So in the previous video, we introduced the concepts of freezing point depression and boiling point elevation with regards to solutions. We said that when you add a solute to a pure solvent, the addition of that solute alters the freezing point and boiling point of the solvent by depressing or lowering the freezing point of the new solution and raising the boiling point of that new solution. So we talked about those two concepts and why that is the case and how that happens. In this video, we're going to start to talk about how can you calculate how much a freezing point is lowered or depressed and how much a boiling point is raised or elevated when adding a solute or an impurity to a solvent or a liquid. So the two equations for freezing point depression and boiling point elevation are listed here, and they look pretty similar. Let's talk about the parts of those equations. So both freezing point depression and boiling point elevation have a constant that is in the equation. For the freezing point depression, that is this Kf. For boiling point elevation, it's this Kb. Those are constants that are associated with the solvent that is in the problem. And what's important to you guys to know is that those constants, those Kf or Kb values, will be given to you. What will also be given to you is this I value. It's called the Van Hoff factor. Talk about it more in other chemistry classes. This I value speaks to number of particles, number of type of particles that your solute contributes. The part you need to know about that is that I will give you the I in both cases. The third part of the freezing point depression and the boiling point elevation equations is this M variable that looks like that's kind of italicized. That M stands for not molarity, but molality. There's that word again, moles, that word that chemists love. We talked previously about molarity as a concentration, a way to express how much of a solute is in a particular volume of solution. This molality is another way to express concentration of solute in solvent. In the next video, we will talk about how to calculate molality based upon information given in the problem. But take-home points from this slide. Freezing point depression and boiling point elevation can both be calculated. They are calculated by these two equations that you'll be able to use on quizzes and exams. They both involve constants that are associated with the solvents. They both involve constants that are associated with the solute, and those constant values, those Kf's or Kb's and I's, will be given to you. You should also know that freezing point depression and boiling point elevation is a colligative property. What that means is that the amount that the freezing point is changed or the boiling point is changed based upon the equation, it depends upon how many number of solute particles you have, not necessarily the type. So we say that freezing point depression and boiling point elevation is a colligative property. The equations to calculate those involve those constants, as well as this new concept of talking about concentration called molality, the little M with the script. We will talk about how to calculate molality in the next video, and then in our final video we will do a practice problem involving molality and freezing point depression.